have started recording. Okay, and I'll also share the earlier recordings with you. You people requested, so I'll either share it on the Google Classroom or through the YouTube. We'll see whatever way works. Okay, yeah. So see, there are two core subjects that you are required to study in your first semester. The first one is computer system architecture and the other one is C++. So on one hand, you are looking at the computer system from the point of view of a programmer, but C++ is a high level language. Okay, beta. So you look at the computer system from the point of view of a high level user there. Okay. There is also something known as low level programming languages. We will be talking about them a bit later. But for the moment, let me tell you, there are low level programming languages are much more closer to the hardware. That means in C++, for example, when you have to declare an integer, a variable, you simply say whether it is an integer or a boolean or a character or an array, and you go on to do your work. That means you can simply declare and start working with them. However, in low-level programming languages, you actually tell the computer system how many bytes to reserve for each variable that you are going to use. Okay, so you are directly concerned with addressing. Okay, so the low-level programming language is again of two types, machine language programming and assembly language programming. When we go further down the low-level languages, that is to the machine language, you even specify the type of instruction format and how to deal with individual bits. Okay, so right now you are working at the with the computer system at the level of a high level programmer, that means using C++, and on the other side, computer system architecture gives you an overall view of the computer system. So you will be able to look at, first of all, the architecture of the computer system. Okay, so from the architecture we see overall, from a very broad perspective, what all components are required in a computer system and what will be the function of each of these systems. Is this clear? What will be the behavior? Mansi Tyagi, Soumya Gupta, I'm admitting you today. Please be on time next time. Soumya Gupta was late last time also, if I remember. Yes or no? Okay. So we have talked about this last time, right? We saw the basic components of a digital computer system, okay, from the point of computer system architecture. And then we saw how these basic components interacted with each other. Do you have any doubt here? Anybody has some doubt here? Yes or no? Am I audible?
No, ma'am.
No.
No,
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 ma'am.
ma'am.
No, ma'am.
No doubt, or I'm not audible?
No doubt. No
Okay,
doubt.
great.
No
Right.
doubt.
So let's proceed, right? So see, the first step is,
No doubt.
okay, good. So the first step towards designing a computer system from a hardware point of view, when we're looking at it from a hardware point of view, is the computer system architecture. Okay. Now, after that, we go on to computer organization, computer system organization, and then computer system design. The design phase is also known as implementation. Okay, so computer system organization, what do we mean? What do we do here? Now, we have already delineated what all components we are going to use in a computer system. That's right? Yes. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Right.
Yes, ma'am.
In organization, see, computer system architecture, uh, uh, we have, we are concerned with what hardware components are there which are connected together to form a computer system, and what is the functionality of each of these components, right? And what do we do in computer organization? In computer organization, we see how these units should be organized. Okay, that means, for instance, you have seen this slide, right? Can the output unit directly be connected to the input unit without the intervention of the storage unit and the CPU? No,
No, ma'am.
no.
No.
No, ma'am.
Okay, what would be the
No, ma'am.
benefit if we simply take the input and pass it back to the user, right? So where should we connect each component, okay, at a high level? Where should we connect? How should we arrange these systems? So it is not as trivial, as simple as it seems to you on the screen right now, that there are only 5 or 6 components that you see on the screen and they have to be arranged. So there are many more high level systems components which are there that need to be decided when we talk about computer system architecture, and many other things, as I told you, which we will be talking about later, as you can see in the last point here. For example, the instruction formats, the how to address the memory optimization, and all those things. So it's not as simple as this, students, but for the first few classes, we've made it very simple so that you can understand the basic concept. Is this clear? So computer system architecture, we delineated what all components we're going to use, and in computer system organization now, we will decide how we are going to arrange and interconnect these systems so as to achieve better performance. So this is one of the goals of computer system organization. Okay, so you can see here, the last point here, the focus is on achieving performance. Okay, so how do we connect? So sometimes, you know, for example, I told you that there are many kinds of memory units. Yes or no? There is a complete hierarchy of memory, I told you. Did I tell you?
Yes,
Yeah.
ma'am.
Yes,
So,
ma'am.
so out of these memories, which memory should be directly connected to the CPU and which should not be directly connected to the CPU? This is just one of the examples that I'm giving to you. Okay. Then, should we have another processor, a complete processor in itself? Not the CPU, but a processor in itself to handle the IO devices, which comes in between the IO devices and the CPU. अभी आप जो देख रहे हो एक simplistic design देख रहे हो जिसमें कि there is input unit at one end, output unit at one end, and you know, perhaps there is no mention of IOP stands for an input output processor, but there is room for an input output processor. Again, this is a discussion that we will be taking in detail later, but the idea that I'm trying to tell you is that when we talk about organization, it is not, you know, simply connect the dots. It is not that simple. There are many things to be kept in mind. Okay, so which memory to directly connect with the CPU? Okay, which component to put in between the IO devices and the CPU so that our processing is faster. Is this clear?
Yes, ma'am.
Okay,
Yes, ma'am.
so the idea is to improve our performance. However, please see the corresponding point on the computer system architecture side. Here in CSA, the focus is on deciding the basic hardware units to be used, which as we had discussed earlier. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yeah. So obviously, please see the first point. The organization is done on the basis of architecture. ठीक है? Is this clear? Okay. So when we go on to design a system, obviously we first need to consider its architecture first. Is this clear?
Yes, ma'am.
Right.
Yes, ma'am.
Now, so computer organization deals with low-level design issues, whereas computer system architecture deals with high-level design issues. Organization involves physical components such as circuit designs, adders, signals and peripherals, etc. Whereas the architectural design or the architecture involves logic. That means the instruction sets, addressing modes, data types, cache optimization, etc. Okay. So, see, now, once we have decided, for example, that we need to have a CPU, the CPU generally has a ALU and a control unit and a memory unit, right? Now, how is, what all components are going to be the part of this, let's say, ALU, that means the arithmetic logic unit, which is inside the CPU, that also comes under organization. And how are they, all those components, how are they arranged, interconnected within the ALU is again something that we deal in computer system organization. Is this clear? So for example,
Yes, ma'am.
in a arithmetic logic unit, we need to have adders, subtractors, okay, shifters, counters. So all those things, what all things are required and how they will be connected is part and parcel of computer system organization. Is this clear? So the distinction between the computer system architecture and computer organization is clear now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Good. So now we come to the next stage, that is computer design, also known as computer system implementation. Okay. Now, what do we mean by computer system design or implementation? As the name suggests, please look at the literal meaning of these words, design and implementation. So we have already seen what all components will be there. We've already seen how they will be interconnected. And now it is time to actually design or implement these systems. So for instance, we talked about that we are going to have one ALU. Please let me tell you that there are systems, different application, depends upon the application. Hamara, just the kind of systems that we are using day to day, they require generally only one control unit and one arithmetic logic unit, okay, and maybe one memory unit. But there may be systems which require multiple ALUs, multiple control, single control unit, but multiple ALUs. Okay, so this thing is decided in the architecture, and then after that, what all components will be there and how they will be arranged inside the ALU in the organization. And then now we come to design. Now, suppose I've decided that I need to have a adder circuit inside the ALU. Okay. So how will I implement that? That means what will be the physical circuit? Okay, what all gates, logic gates will be used to construct that circuit? We'll come to the topic of logic gates in a couple of classes. So we will talk about what is a logic gate, what are different types of logic gates there. But for the timing, just to give you an idea, so what all logic gates are going to be there so that, what kind of a logic circuit we can design for the adder so that it is so that it is optimal. Okay, it gives optimal performance. That is the subject matter of computer system design, also known as computer system implementation. Is this clear? Yes or no?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, good.
Yes, ma'am.
Good. So, computer design is concerned with the hardware design of a computer, and once the architectural and organizational specifications are formulated, task of a designer is to develop the hardware in accordance with these specifications. Okay, so the focus here is on what hardware is being used and what parts are to be connected. Is this clear? Right?
Yes, ma'am.
Okay, so now let us look at a roadmap. As in, though your, please see that the name of your course is Computer System Architecture, but you will be studying some elements of all three of these, that is the computer architecture, organization, and design in this course. Okay, you will be studying some elements of all of these in your course. So we'll be following this textbook that I already told you about, Computer System Architecture by N. Morris Manor. Uh, mm, the publisher is Pearson Education. Third edition, 2004 reprint is in your guidelines, that is prescribed in your guidelines. So there are different chapters in this book which correspond to each of these topics that we have discussed. So, for example, chapter number 1, 2, 3, and 4, where we talk about logic circuits, digital components, data representation, and register transfer and microoperations. These chapters deal with not only organization part but also start detailing something about, they also give us, they chapter takes us deep down to computer system design. Okay, then detailed design is covered in chapter number 5, basic computer organization and design. This is the chapter 5, on which your practical is based. Okay, so that is why you see we have to, there are so many chapters which need to be first done and completed so that we lay the foundations and come up to chapter 5, which lays the foundation for your practicals. So that is why there is a little delay in actually starting with hands-on practicals for our CSA course. Okay. So chapter 5, chapter 6, programming the basic computer, microprogrammed control, and computer arithmetic. These are the chapters in your book which focus on detailed design. Okay, आपको इसमें से chapter 5 ही करना है. अब जो लेटेस्ट गाइडलाइंस है चैप्टर 5 है और चैप्टर 6 का एक सेक्शन है जो हमारे को करना है, which we will do as per the latest guidelines. Earlier we used to have all these chapters, okay, some part of all these chapters. Now the next is architecture. So architecture is majorly covered in CPU, which is the 8th chapter, and 9th chapter, pipelining and vector processing. So here you will see we will talk about parallel systems, where as I was telling you, there might be a single control unit and there may be multiple ALUs and different variations of these kind of processors. Uh, then chapter 11 and 12 talk about both organization as well as architecture, where we talk about IO organization and memory organization. So again, I think chapter 12 is now out of your guidelines. Uh, we will be doing chapter 11, but it is good to know what all topics come under which topic. So that is why I've tried to give you a clear roadmap at the very beginning, so that you can look at this textbook and understand when you are going through the topics that, whether you're looking at it from the point of view of computer system architecture or organization or design. Okay, is this clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Anything that
ma'am.
you want me to repeat?
No, ma'am.
Okay, good. Right. So just a sec, let me start the other. Let me begin with the next topic. Yeah, hello, who is this? Who has joined in? Yeah. But may I know who has just joined in? What's your name? I couldn't. See, all of you are requested to join in on time. Okay.
Okay.
Give me a minute. I'll just share the second presentation with you. Can you see my screen? Is the presentation visible to you all?
Yes,
Yes,
ma'am.
ma'am.
Yes,
ma'am.
So we are going to
Yes,
be
ma'am.
talking about logic gates now. Okay, we are going to
Yes,
start
ma'am.
with logic gates. Okay. So what are logic gates? See, the very basic unit of an integrated circuit, या जिसको आप generally you call an electronic circuit, okay? The most basic unit is known as a gate, okay? The most fundamental unit in IC stands for integrated circuit, is called a logic gate, okay? Now, what is the function of these logic gates? So these logic gates are required to perform logical operations, for instance, ANDing, ORing, complementing, and a combination, some manifestation, some of these basic three functions joined together. So there are three basic logic operations: and, or, and not. Not is also known as complement. Okay, please repeat with me. What are the three basic logical operations in a computer system? And,
And
Or,
not,
and,
not,
or, and not.
not.
Let's do it again. And,
And,
or,
or, not.
not.
so these are the three basic, yes, these are the three basic logical operations, and there are many other logical operations which can be then done by uh, joining these by a manipulation of these basic operations. Okay, but any of these operations, logical operations, are done using what? They are done using hardware components which are known as logic gates. Is this clear?
Yes, ma'am. Yes, ma'am.
Okay,
Yes,
good.
ma'am.
So on your screen, you can you see my mouse pointer?
Yes, ma'am.
Yes, ma'am.
Okay. So on your screen, you can see the first gate, which is known as the AND gate. Okay, so this is what? This is a symbolic representation. This is how we draw. This is the symbol that we draw on paper. Whenever it is drawn, we recognize it as AND gate. AND gate means AND logic gate. Is this clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So if you remember, children, I told you that there are three basic kinds of operations which are central to any computer system. They are arithmetic operations,
Memory unit.
no,
Logical,
logical operations,
Logical operation.
and
Control unit.
relational.
the
Control unit.
register operations. Let's do them again.
Okay, relational.
The arithmetic operations, logical operations, and the
Logical operation.
register
Register.
transfer operations. Okay, so we are going to be looking at logical
Logic
operations now.
operation.
Okay, is this clear? Okay. Now, mostly the logic gates, they take inputs. ये आप देख रहे हैं ये AND gate जो यहाँ पर बना हुआ है. There are two inputs to this AND gate. Okay, and there is a single output. Okay, there are two inputs here and there is a single output. So what are these inputs? These inputs are binary inputs. These inputs are binary inputs. So they can either be on or off, as we discussed yesterday in the last class. Yes, so we said that any electronic component basically works on two stable states with an on and an off, a 1 or a 0. So what do we input to our AND gate? 1 or a 0, and even on this input we input either a 1 or a 0. Is this clear? And what is the output that this AND gate is going to give me? Depending upon the definition of what do we mean by the AND operation which this gate is required to perform, this gate will give me an output, okay, based upon the inputs, and what this particular gate is required to do, it will give me an output which will be again in the form of either a 1 or a 0. Is this clear? So
Yes, ma'am.
I can say that the inputs to the logic gates are binary and the outputs are also always binary. Is this clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So what kind of output we get? The third gate that you see here is the OR gate. If I give the same inputs to the AND gate and the OR gate, I may get different output from both, but which will depend upon their basic function definition, as in, you know, what an AND gate is required to do and what an OR gate is required to do, but the output will be either 1 or a 0. So this is common for all logic gates, that they take binary input and they give out binary output. Any problem up till now?
No,
No,
ma'am.
ma'am. No, ma'am.
Okay, let us look at this NOT gate now. So you see, this is called a unary gate. Okay, these are binary gates, and an OR, NAND, NOR, XOR, XNOR that you see here are all binary gates, whereas NOT is a unary gate because it only takes one input. Okay, it takes one input and it passes on only one output. Clear? So the number of inputs may vary, but they will always be, the nature will always be binary. Clear? Okay, now before we go further, let us talk about what is a truth table so that we can now look at the logic gates in detail. Clear? So what is a truth table? Let's see. A truth table tabulates for a particular algebraic expression the output values corresponding to all possible input combinations. Okay, now what does this mean? This simply means that suppose I have two variables. Okay, suppose I have two variables. Okay, let me just let me open the whiteboard for you so that I can write it down for you. Students, can you see my whiteboard?
No, ma'am.
No, ma'am.
No, ma'am.
Now,
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
okay, good, good, good. Okay, so suppose, let's say I have one variable, let's say x. Okay, I have one variable x. Okay, now if I say this is a variable, what do we mean by the word variable? आपने किया होगा ये C++ में अभी?
Variable is a container to store data.
Yes. It is a container to store data, but what is the difference between a variable and a constant then? A constant
Ma'am,
is
it
always.
can store any value, a junk value also.
Yes, the important thing to say about a variable is that it not only stores the value, but the value that it stores can vary over the time, and that is why we we call it a variable. Yes or no? Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, good. So let's say x is a binary variable. Now I've modified it. When I say it is a binary variable, now what do you mean by it?
Can store two values.
It can,
1 or 0.
no, it cannot store two values. Please look at these distinctions very clearly. It cannot store two values. It can only store one value. Since it is one variable, it can only store one value. But when I say it is a binary variable, it can store one of only two values, which happens to be, in our case, which will have to be either a 0 or a 1. Okay, because these are the two values we've said make sense to us when we talk about digital electronics. Is this clear? Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
So
ma'am.
when I have a single variable x, what are the two values that it can have? 0 and 1. Yes? Now suppose I talk about two variables x and y. Can you see my blackboard?
Yes, ma'am.
Yes.
Yes.
So x in itself can have two values, 0 and 1, and y in itself can also have two values individually, 0 and 1, right? But when I talk about x and y together now, okay, these are two Boolean variables and I'm talking about them together, then what are the values that they can take? Let's see, x, y. So what are the values that they can take? See, the first case is that when x is 0, y is also 0.
Yes. Yes, yes, ma'am.
Yes. The other case may be that x was 0, but y could have taken the value 1.
One.
Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Because
ma'am.
they are multiple variables, they are not related with each other, right? Now, the other case is that x itself could have been 1 in the very first place. And at that time, y was 0. Yes or no?
Yes,
Yes, ma'am.
ma'am.
Yes, ma'am.
And if x was 1, then y was also
1.
1. This
1.
is the fourth case. Yes or no?
Yes,
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 ma'am.
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 Can anybody tell me if you know of any other case? Can you think of any other case that this might happen?
No, ma'am. These are
No,
the
ma'am.
only
No,
case.
ma'am.
Can they
These are
take
the
any
Only
other
four
cases.
combination of
cases.
values?
No,
No,
ma'am.
ma'am.
No, ma'am. No, ma'am.
No, ma'am.
No,
Right.
ma'am.
So, so these two variables, right? If there are two variables, we saw that when there was a single variable, how many values could it take?
Two.
Two
When there was
values.
a single variable, how many values could it take? Two.
2.
Now there are how many variables?
Two.
Now there are
Two
two
variables.
variables.
2
Two
values.
variables.
And how many values can it take?
Four.
4.
Four.
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 It can take four values, right? Now let us talk about three variables and see how many values can they take. So this is, I am
Okay.
building this very slowly with you. Why? Because I am going to use this almost in every class from now onwards. So please see, now suppose we take three values, three Boolean variables, x, y, and z. Okay, x, y, and z. Right. Now let us see what all values can these take. So these values will be 0, 0, 0. I want you to work on them later. आप खुद बाद में करके देखिए please. Whether you can, I'm just writing down the values. Whether you can find any other combination of values that these three variables can take. Okay. Yeah. So just give me a minute. Okay. We see these will be the only values that you will be able to ever list using three variables. So these will be the only unique combinations. Okay, I want you to work on them on your notebook. अपने आप try कीजिए. Just try forming patterns from these and you will see that there are 8 combinations. Is this clear? How many combinations are these? Can you count them for me?
8. 8.
Eight.
Ma'am, there are 8 combinations.
8. Very good. So in general, you will find now after this, just take it to the next level. That means take X, Y, Z, W, that is 4 variables, and try forming combinations from them. You will always see that whenever we have
16.
some n variables,
16.
the number of values that we have is 2 raised to the power of n. Okay, it is always 2 raised to the power of n. I don't think I have a raised to operator here on the jam, okay, on this blackboard. So just a sec. Okay, this is not 2n, please mind you, this is not 2n. What is this? This is 2 raised to the
2 raised
power
to the
The
of
power
power of
n.
10.
2 raised to the power of n. Because see, first time when we had a single variable, how many values were there? 2 raised to the power of 1 is equal to 2. Next time when we had two two Boolean variables, we had 2 raised to the power of 2 is equal to 4 values. Next time, when we had 3 variables, how many values were there? 2 raised to the power of 3 is equal to
3.
8. So when I have 4 variables, how many distinct combination of the values will I have?
16.
16.
16.
16, yes. And in general, if I have n variables, then it will be 2 raised to the
2
power
raised to the
of
power n.
n. Is this clear to everybody?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, good, good. So let's go back to our presentation. I'll just share it with you. So what is a truth table? So a truth table basically lists down all the input value combinations. So suppose I am talking about an expression, okay, which involves two binary variables. A truth table will tabulate, that means it will put in the form of a table all the values that these two variables can take. क्या क्या values होंगी वो? 0 0 0 1 1 0 1 1 as we just saw. ठीक है? And then it will list the output corresponding to each of these input combinations. Okay? Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Who is not clear? Who is not clear?
Ma'am, can you explain one more time?
Yes, I can. So what is a truth table? A truth table is a table, right? It is a simple table which shows us the inputs, the value of inputs which are going to, in our case right now when we are talking about a logic gate, then it will show us the inputs which are going into a particular logic gate and the outputs that are coming from that logic gate. Okay, so on the input side, it will show me the combination of all possible values that those variables can take, and on the output side, it will show me the output corresponding to those input combinations which the logic gate will give me. Okay, now we will see this in a while. Let's start with the AND gate first. So here you can see the truth table. Can you see here the truth table?
Yes,
Yes,
ma'am.
ma'am.
Yes
Yes,
or no? So in this truth table, my mouse pointer is visible to you.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Okay, good. So in this truth table, you can see on one hand there are two variables, Boolean variables listed, which are A and B, and on the right hand side there is a Boolean variable called Y. Okay, this is the output variable. So you can see on one hand this truth table lists all possible input combinations जो हमने अभी discuss किए हैं, yes or no?
Yes, ma'am.
And on the other side,
Yes, ma'am.
it lists the corresponding output which this particular gate will give depending upon the definition of this gate. Yes?
Yes, ma'am.
Yes, ma'am.
Okay. So now let us proceed to AND gate. So the first gate here that you see is AND gate. Let me just look at the time. So children, just give me a break. Give me a break. 1 minute. Huh?